WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Good day, learners. You're welcome to Eko Learner Support for WAEC and NECO candidates. I'll be your physics tutor for today's lesson. Let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Today, we'll be talking about capillarity and surface tension. Let's look at the learning objectives together. By the end of the lesson, you as a student will be able to define capillarity and surface tension. You'll also be able to give examples of surface tension, and you'll also be able to describe the applications of capillarity and surface tension. Capillarity. Capillarity is the combined effect of cohesive and adhesive force that causes water and other liquids to rise in a thin tubes or other constricted spaces. Capillary action is the movement of water within spaces of a porous material due to the force of adhesion, cohesion, and surface tension. The main aim of the capillary tube is to reduce pressure. It is also used in laboratories for collecting the different samples of liquid, checking on concentrations, molarity, and etc. Capillary tubes can be used in refrigerator to control the flow of refrigerants. And this diagram here is showing you different types of tubes and how the liquids rose in each one of them, depending on their size and how it allows the liquid to rise in each one of them. Application of capillarity in ink pens. The capillary action of the pen nibs draw ink from the reservoir onto the paper as the liquid wicks through the porous pen tip. It also causes the entire towel to become wet if one end of a towel is dipped in a bucket of water and the other hand hangs over the bucket. I believe you have experienced this one way or the other. You'll be amazed that it's not all the part of the towel that is deep into the bucket of water, but due to capillarity, once an end is in the water, the other thread draws the water. Water is also delivered to the leaves at the apex of even the tallest trees due to capillary rise. Another application is also placing a straw in a glass of water. I bet you imagine when you get a bottle of drink, as soon as you put your straw in it, you just see the liquid rising through it, and you'll be amazed because we tell you physics is part of what we do every day. The oil in the wick of a lamp, or when we use kerosene stove, you understand what I mean by the wick, rises due to the capillary action of the threads in the wick. Now, in our circulatory system, capillaries facilitate the exchange of oxygen, nutrients, and waste products between the bloodstream and surrounding tissues. You see that it is an essential we cannot afford to do it. This diagram depicts the applications I've explained before. You can see this is a plant growing that in we have different liquids, and you can see it absorbing the liquid. This is the back of the refrigerator, and this is the coil at the back of the refrigerator, and you can see the straw in the glass cup, And this is how the capillary action takes place from a tree through the apex of the leaves. And we have three types of narrow tubes here. You can see the level at which the water rises in the tube depending on the size of the tubes. And this is also another very good example. You see, the larger the tube is and the narrower it is, then it depends on the type of liquid we are talking about. If it is mercury, definitely it's not going to, it rises more. It does not even rise in a narrow tube, but more of the wider tube. But if it is ordinary water or water mixed with soap, definitely it rises more. Now, surface tension. Surface tension of a liquid is a force that mainly acts to reduce the surface area of a liquid. The surface tension of a liquid results from an imbalance of intermolecular attractive forces, the cohesive force between molecules. A molecule in the bulk liquid experiences cohesive force with other molecules in all directions. A molecule at the surface of a liquid experiences only net inward cohesive force, just as we can see in this diagram. And we have the droplet when it rains. We also have a pin that is what? Floating on the surface of a liquid in a jar. And here, you wonder how you have droplets hanging to leaves when rain falls. Examples of surface tension include insects walking on water. We have the floating of a needle on the surface of the water, rainproof materials or tents like our canopies, where the surface tension of water will breach the pores in the tent material. Clinical test for jaundice. We also have surface tension disinfectants, and it also causes little raindrops to adhere to your windows when rain falls. You just be amazed that, okay, rain is falling and you have all these droplets on it. Then it also generates bubbles in your sink when you add detergents. Methods to reduce surface tension. When there is increase in temperature, which is heating of water, can reduce surface tension. Spreading oil or oily compounds on the surface of water will also reduce surface tension, a method used by ancient sailors to escape rough seas. Some liquids such as oil and kerosene can also destroy surface tension in water. Then we have dissolving common salt in water also reduces surface tension. Application of surface tension. Surface tension has a huge role in our daily lives, either in health or other industrial processes. There are so many techniques that have been developed to modify surface tension. Some of the examples are why small insects such as the water strider can walk on the surface of the water because their weight is very less, so they can't penetrate the water. 2, disinfectants are mainly the solution to low surface tension, so that when you use them in the field, they can float on the water and spread out on the cells to destroy them. You take note when you put your Izal or your Dettol in your water, you see it spreads over the water. Then we also have soap and detergents. They also work as the basis of surface tension. They lower the surface tension of the water so that the soap and detergents easily soak into the pores and the holes. We have the water bubbles. They are around because the surface tension of water provides the tension to form the bubbles with the water, and the surface tension minimizes the bubbles into spherical shapes. And these are also the spherical shapes you see on your window pane when rain falls or on the body of the leaves. Then a small needle can be floated on the surface of water due to surface tension. That brings us to our practice question. Why does oil spread over the surface of water? Why are raindrops spherical? Explain why rainwaters form beads on the surface of a leaf. Is there any difference in surface value among tap water and distilled water? Then what is the main cause of capillarity? So I believe during the course of the lesson and as the lesson progresses, you should have answers to this practice question. I'll leave you to get your own answer in the next 30 seconds and I'll be right back to cross-check with you. Thank you. Welcome back. So let's look at the practice question and answers to the practice question. I believe you have the correct answers with you. Yes. The first question. Oil spreads over the surface of the water mainly because the surface tension of oil is less than the surface tension of water. That is why oil will spread on the surface of water. Secondly, the raindrops are spherical because of the coercive force between the rainwater molecules and the surface tension of the water molecules. That's why it's spherical. Third, as the surface of the leaf is waxy, so the water adheres weakly to wax. Remember, it cannot stay on it, and strongly to itself. Hence, they form clusters into drops. The surface tension of water gives them spherical shapes. The fourth answer. The surface tension value depends on the number of impurities there are in the water. So if we observe clearly, there are more impurities in the tap water than the distilled water. And lastly, capillary action or capillarity is caused when the adhesive force is stronger than the coercive force. I am very, very sure that we have the same answer. It might be in different forms or written differently, but I'm sure you got the answer to the practice question. For further questions, comments, observation, kindly send it to the social media handles on the screen. Thank you for your time and see you in the next class. Bye.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Good day, learners. You're welcome to Eko Learners Support for WAEC and NECO candidates. I am going to be your physics instructor for today's lesson. Come along with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Machines. That is our topic for today. Let's go together and see our learning objectives. By the end of the lesson, you as a student will be able to define machine, list type of machine with explanation, answer frequently asked questions on machines. A machine is a device that helps lift a heavy load, speed up motion, or change the direction of the force in the desired direction. Since the beginning of time, humans have developed devices and tools to make work easier. Making work easier is something we all like to do. Throughout history, humans have developed many types of machines to make work more efficient and effective. Machines in factories are used to streamline the manufacturing of products and packaging of products over the years. Today, in giant manufacturing warehouses, factory machines are used to ship products. However, all machines can be broken down into a few simple components which have few or no moving parts. Let's take a look at these simple machines. Simple machines and their examples. We have the lever, and an example is a crowbar, claw hammer, a pair of pliers, etc. You have the inclined plane. Examples of inclined planes are ramps, staircases, hilly roads, etc. We have the wedge, and examples of the wedge are the knife, an axe, a plow, etc. Then we have the screw. An example of a screw is the screw bolts. The inclined plane. An inclined plane is a sloping plane used to raise heavy bodies. Inclined planes make it easier to lift objects to greater heights. There are two ways to raise an object. It can either be raised by lifting it straight or by pushing it diagonally up. A few everyday examples of inclined planes include sidewalk ramps, highway access ramps, inclined conveyor belts, and switchback roads. Wheel and axle. Wheel and axle make work easier by moving objects across distances. The wheel and axle greatly reduces the friction involved in moving an object. The wheel, which is the round ends we have here, you can see depends on how you turn it, depending on if you are either fetching, with this particular picture, if you are fetching water from the well, or you are bringing the water, you are returning the bucket back to the well. So the turning of the axle, which is the cylindrical post, by the time you turn it this way, you have already applied effort. And the bucket here is the one that is what? That is the load. That is what you are getting easily done with the aid of the wheel and axle. So looking at the direction of the twine on the cylindrical post. So if we turn it this way, definitely you are releasing the bucket into the well to fetch water with little or no effort. And by the time you turn it the other way around, definitely is getting the water out of the well. Imagine you don't have this. And when we talk about well, they are always very, very deep. You throwing the bucket into the well does not give you certainty that you come out with a bucket full of water. But with this one, effortlessly, you are sure of getting, as long as there is water in the well, you are sure of what? Pulling water from the well. So, before the invention of wheels, the amount of loads and distance through which we carry load over land was very, very limited. So, it is easier to roll a 2,000 kilogram block of stone using logs placed under it to push it. The pulley. Instead of an axle, a wheel could also rotate a rope, cord, or belt. The variation of the wheel and axle is the pulley. In a pulley, a cord wraps around a wheel. When the wheel rotates, which is what we have here, you can see the wheel here and the cord is what? Wrapped around it. When the wheel rotates, the wheel's rotation can be used to raise or lower objects. We see it when they are building bridges or they are building story buildings, and it is used to either what? To raise or lower objects, making the work easier. Imagine a large slab, even 50 men cannot pull it, but with the head of a pulley, with the rope tied around, the hook is now attached to another rope that is tied on whatever load you want to carry. It makes it easier for lifting or lowering. A pulley system is necessary to hoist or flag on a flag pole. That is our flag. You want to hoist it on the pole or you want to bring it down. A rope is attached to the pulley to raise and lower the flag more easily. As we all know, for you to hoist a flag, it has to be on a very tall pole. The lever. A lever is a tool that is used to pry objects loose. Levers are also used to lift objects. A lever has an arm that turns against a fulcrum. Exerting a force on one end of the pivot creates a force on the other end of the lever. Let's look at what you have. This is the arm, this is the fulcrum, and this is the load. This is what we want to lift up. So definitely your effort is here. That is where you are exerting the force. So The applied force is either increased or decreased based on the distance from the fulcrum to the load. This is the fulcrum and this is the load. So it depends on the distance from here that determines either we are going to increase or decrease the applied force. The fulcrum to the load and from the fulcrum to the effort, yes. The applied force is either increased or decreased based on the distance of the fulcrum to the load or from the fulcrum to the effort. A few examples of levers are the hammer that we use to pry nails. Excuse me. A few examples of levers are the hammers we use to pry nails loose and the kid's favorite seesaw. The screw. An inclined plane wrapped around a shaft is known as a screw. The two primary functions of a screw are to hold things together or to lift objects. The threading around the shaft, this threading, as you can see, threading around the shaft in a screw makes it efficient, makes it an efficient tool to hold things together. The thread grips the surrounding material like teeth, resulting in a secure hold. A few examples of screws include screw, bolt, clamp, spinning tool, and spiral staircase. A car jack is also a very good example of a screw used to lift something, definitely large objects, majorly cars. The wedge. A wedge is a simple machine that is used to break apart substances by applying force. A nail is a common example of a wedge. In a nail, the force is applied to the widespread edge area. This applied force is concentrated on a small point area where the force is exerted. That is the mouth of the nail, the tip of the nail. At this point, the force is magnified and enables the force to pierce through objects, just like we have here, to pierce through objects. As the nail sinks into the object, the wedge shape at the point of the nail moves forward and forces the object apart. So let's look at this wedge now. This is an hammer. You can see the other point head. So as he applied force on this flat area, definitely the force is more here and it creates space or passage for the material. Our practice question. I believe you now know what a machine is. So what is a simple machine? Is broom a simple machine? Because we said anything that makes work easier and faster. Give one example of a lever, inclined plane, and wedge. And what a compound machine? I'll be right back for your answers. Yes, welcome back. Let's look at our answers together and let's see if it correlates with yours. Answers to practice questions. What is a simple machine? A machine is a device that helps lift a heavy load, speed up motion, or change the direction of the force in the desired direction. Is broom a machine? Yes. The broom is an example of a lever. The pivot, which is the handle of the broom at the top of the fulcrum, push the handle near the middle, which is the effort, by the time you hold it like this, which is the effort. So the bristles at the other hand will sweep across the floor. So a broom is an example of what? A machine. So if you have a broom, you want to sweep this area and you want to pick the area, one does it faster and neater. Example of a lever is a crowbar, claw hammer, a pair of pliers. So if you choose any of this answer, you are definitely on the right track. Example of an inclined plane, we have the ramps, the staircases, hilly roads, etc. Example of a wedge. We have the knife, the axe, the plow, etc. And what is a compound machine? A compound machine is a device that combines two or more simple machines. A wheelbarrow is an example of a compound machine. In a wheelbarrow, the functionality of a wheel and axle is combined with that of a lever. Thank you for your time, for your questions, comments, and observations. Kindly direct it to the link of our social handles posted on the screen. Thank you once again and see you in the next class.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.